All right, so here is the test review. So number one says if y varies directly as x, and when y equals 35, when x equals 7, find y when x equals 11. So with this one here, first thing we're going to do is we're going to find the varies directly equation. So that's going to be y equals a times x. Then we're going to substitute our numbers in. We said y is 35 and x is 7. So to solve this for a, we're just going to divide by 7. And we get that a is equal to 5. So my equation for this one would be y is equal to 5x. Then I'm going to figure out when what y is when x is 11. So y equals 5 times 11, which is 55. All right, for the next one, it says if y varies inversely as x, so that's going to be y equals a over x, and y equals 6 when x equals 5, so let's go ahead and plug those in. So y is 6 when x is 5. So we multiply both sides by 5, we get a is equal to 30. So my equation is y equals 30 divided by x. And then it says find y when x equals 10, so y equals 30 divided by 10, which is going to be 3. All right, for this next one here, it says it's an application of the inverse and direct variation. So it says the number of gallons of gas a car uses varies directly with the number of miles driven. Suppose that a car uses 3 gallons in going 120 miles. Find the constant variation and write a particular equation expressing the gallons in terms of miles. How many gallons would, I'm assuming the car be, how many gallons would be used in driving 300 miles? Okay, so we have gallons in terms of miles. So we can, you can use y or x or g or m. I'll make this y and x. So it is, let's see, where's it at? Direct variation. So y equals ax. So we're going to go ahead and plug in gallons is 3. A times miles is 120. If we divide both sides by 120, A is equal to 1 over 40. So my particular equation would be y equals 1/40 of x. The next question says how many gallons would be used in driving 300 miles. So y equals 1/40 times 300. All right, I'm just going to put this in the calculator real quick. And we get 7.5, and it would be, I guess, gallons this time. And there you go. All right, on to the next one. The number n of photos your digital camera can store varies inversely with the average size s in megapixels of the photos. Your digital camera can store 54 photos when the average photo size is 1.92 megapixels. Write a model that gives n as a function of s. How many photos can your camera store when the average photo size is 3.87 megapixels? All right, so here we're talking about inverse. And it actually tells us the variable. It says write a model that gives n as a function of s. So n being the number of photos, and a being the size of the photos. All right, right now it says your digital camera can store 54 photos when the average photo size is 1.92 megapixels. So to figure this out, we're going to multiply 54 times 1.92. And I got A is equal to 103.68. So my particular equation is n equals 103.68 over s. Then it says how many photos can your camera store when the average photo size is 3.87 megapixels. So n equals 103.68 divided by 3.87. So we're going to go ahead and divide those real quick. So I get approximately 26.79, but we know that we're dealing with the memory of a camera here. So it's not going to round up to 27 in real life. It's going to say it rounds down to 26 photos. There you go. All right, for 5 and 6, it wants us to graph it, and you gotta define or figure out if it's like a transformational one because it has a number at the top, which these two would be. A simple one would have x to the first on the top and x to the first on the bottom as the highest degrees. And then general ones have at least one on the top and the bottom that is over like x on the top or x on the bottom and then x squared or x cubed, whatever part it's going to be. All right, so the first thing I notice is that we have a number at the top, so this is transformational. So we know this goes to the left 1, so my vertical asymptote is x equals -1. You can also take the denominator and set it equal to 0, and you get x equals -1. We know this is our k value, it's -3, so our horizontal asymptote y equals -3. My domain restriction is the vertical asymptote, x cannot equal -1. My range is going to be the horizontal asymptote, so y cannot equal -3. So let's go over here and graph -1. And y equals -3. 1, 2, 3. All right, now, since my a value is positive, then my branches will be in quadrants 1 and 3. All right, on to the next problem. All right, for the next one, again, we have a transformational one, and the reason why is because there is a number at the top. Okay, so vertical asymptote, again, we can set the denominator equal to 0, or just understand that it's going left 3. That's why we get x equals -3. For our horizontal asymptote, hopefully you see that k is +1, so y is equal to 1. So my domain restriction, x cannot equal the vertical asymptote, and the range is y cannot equal the horizontal asymptote. And now we go ahead and graph this. And now, originally they'd be in 1 and 3, but since my a value is negative, they're now going to shift to 2 and 4 because they reflect across the x-axis. All right, there's that there. All right, now we're on to, this says name the vertical asymptotes, horizontal asymptotes, and removable discontinuities, which are the holes. Okay, so we're just going to go through those steps. So the first thing we do is we look at the horizontal asymptote. So where is the degree highest? So the degree highest, they are the same, x to the first, x to the first. So what we're going to do is we're going to divide them. 2x divided by x. So my horizontal asymptote is y is equal to 2. Next, we go to our domain. So for our domain, we factor the denominator and what values make it equal to 0. So in this case, -3 plus 3 is 0. So my restriction is x cannot equal -3. Now for my RD, I attempt to factor the numerator, and actually I can factor out a 2. And we see that the x plus 3's will cancel, leaving me with the constant of 2. So whatever we cross out, we cancel, which is going to be -3. And now for my y value of my hole, usually we take -3 and we plug it in, but our simplified equation is just a constant, so y automatically equals 2. And vertical asymptote, there is no denominator and there's no variable in the denominator, so there's going to be no vertical asymptote here. All right, on to number 8. So for number 8, horizontal asymptote, they are the same degree, so y equals x squared divided by x squared, which is 1. For my domain, I'm going to factor the denominator, x plus 6, x minus 6. So x cannot equal -6 or +6. For my hole, I'm going to factor the top. That's going to be x plus 5, x minus 3. So x squared, -3 plus 5 is 2, and -15. All right, that's correct. So for my RD, you notice there are no common factors on the top and the bottom, so the RD is none. This time, the vertical asymptote, I do have 2. I have x plus 6, so I set that equal to 0. And I have x minus 6, I also set that equal to 0. So when I subtract the 6, I get x equals -6. When I add the 6, I get x equals positive 6. So there's two different vertical asymptotes there. All right, on through to 9 and 10. All right, for number 9, we once again see that we have x squared and x squared. So we're going to divide those, and x squared divided by x squared is 1. For my domain, I'm going to factor the denominator. They're both divisible by x. So for my domain restrictions, what makes the denominator 0? Well, 3 minus 3 is 0. And this x can just be the value of 0, and that makes it 0 as well. For my RD, I'm going to factor the numerator. So that's going to be x plus 4, x minus 3. We see the x minus 3s are common factors, so we cross those out. We take what we crossed out, x minus 3, we set that equal to 0, and we do get x equals to 3. Now we take 3 and we plug it in, so y equals 3 plus 4 over 3, which is 7/3, and that's my y value of the whole. And then for my vertical asymptote, I still have x in the denominator, so we set that equal to 0, and it's actually solved, x equals 0. All right, for number 10, this one, we can see the highest degree on the top is x squared, on the bottom is x, so the higher power is on the top, which is going to be no horizontal asymptote, so none. For my domain, I cannot factor the denominator, so 3 minus 3 is 0, so my excluded value is going to be positive 3. For my whole, I'm going to go ahead and factor this. Let's see if I can do this real quick. So we have x minus 5, x plus 2. So x squared, 2x minus 5x negative 3x negative 10, so that's correct. Notice there are no common factors on the top and the bottom, so that's going to be none. My vertical asymptote, I have x minus 3 in the bottom of the denominator, so I set x minus 3 equal to 0, and I get x is equal to 3. On to 11 and 12. So for number 11, we can see that the highest degree is at the bottom. X squared is bigger than x, so y is equal to 0. For my domain, we're going to factor this, so x minus 6, x plus 2. All right, so my domain restrictions, 6 minus 6, so 6 makes it 0, and negative 2 plus 2, so negative 2. For my RD, there's nothing to factor on the top, so I'm going to write x plus 2 at the top, and we see we have a common factor of x plus 2. So we cross that out, rewrite it in a simplified form. We take what we crossed out, x plus 2, we set that equal to 0. If we were to subtract 2, we get x is equal to negative 2. Then we take negative 2 and we plug it into the simplified equation. And we get negative 1/8. And last, vertical asymptote, we do have x minus 6 in the denominator. We set that equal to 0. We add the 6, so x is equal to 6. All right, now for this last one here, let's go and see what happens here. I will have to factor these. Let's go and take a look. Well, the first thing we can do is if we look at this, we see that the powers for the horizontal asymptote are the same, x squared, x squared. So we do y equals 2x squared over 3x squared. The x squareds cancel out. So y equals 2/3. That is our horizontal asymptote. For our domain, I'm actually going to do the x method. So let's see, I'll do it right here. So we have negative 14 dividing by 3. 3 times 15 is 45. So we could do, let's see. All right, let's see what we get. So 9 and 5. 9. Negative 9, negative 5. Negative 9 minus 5 is negative 14. Negative times negative is positive. 9 times 5 is 45. Okay. We can reduce this to a negative 3. So we get x minus 3. And on the other side, it can't reduce. So I bring the 3 in front of the x. So 3x minus 5. So my domain restrictions to make the denominator 0 would be 3 minus 3. So 3. This one would actually be positive 5 thirds, right? Because 3 divided by 3 is 1, 1 times 5 is 5, and then 5 minus 5 is 0, so 5 thirds. For my RD, it's a little bit different. Now I have to actually factor the numerator. So negative 5, negative 6 on the bottom, dividing by 2. So this would be, let's see, negative 6 and positive 1. Let's verify it. Negative 6 plus 1 is negative 5. Negative 6 times 1 is negative 6. That works. Negative 6 over 2 is negative 3. So that's going to be x minus 3. And 1 over 2 does not reduce, so we can bring the 2 in front to x plus 1. All right, so we see that the x minus 3's cancel out. So we take x minus 3, set that equal to 0 and solve it. X is equal to 3. To get the y value, we plug it into the simplified equation. So 2 times 3 plus 1 over 3 times 3 minus 5. 2 times 3 is 6. 6 plus 1 is 7. 3 times 3 is 9. 9 minus 5 is 4. So we have a whole at 3 comma 7/4. And last but not least, our vertical asymptote, we take 3x minus 5. We set that equal to 0. So we add the 5 and then divide by 3. So x equals 5 thirds.